like this if you come to the first figure. So you have done this topic in the practical, this figure, but you have not done this in theory. It will be done soon. Attend the classes regularly, it will be done soon. Hematology, a bit of hematology is still left to be discussed. Very small part. Immunity, a part of immunity that is in your syllabus, it is a part of hematology only, immunity. There was a class today at 2 p.m. I don't know how many have attended regular class. So that's another part of it is left, which will be done next Monday. So this topic, this is about, obviously this is about blood grouping and blood typing. So some theoretical aspects regarding it will be discussed in the next 3 days. Okay, next 3 days means in the practical classes, batch wise. One batch tomorrow, one batch on Friday, one batch this Saturday. But whatever you know from whatever you have done in the laboratory, from that you can answer. If this figure is given, say a objective structured question, you will be facing auspice and right from the first internal. Last time we did not keep it, but students are facing various problems in the final. So we kept the auspice for the second and third internals only, but better to do it from now, whatever has been covered. Not most of the auspice can't be framed right now, whatever has been done till now, but some can be framed. So you get this figure, anything can be asked. Now for the auspice in the viva, if a figure is kept in front of you, then there can be extensive discussions in the viva. Say the person who is taking the viva, he or she is in control, he can ask anything. But about for the auspice, you will get some very short answer type questions. So suppose a pointer ta আছে কি থাকলে না বেশি লাগবে না না হলেও হবে কাজ করছে তো suppose it is asked a particular what is this solution in the yellow colored bottle or container. So what will you say? What is that? It is written already, so you can read that and say. So this is artificial, so that is what is wanted. This is not natural. So whatever the agglutinogens and in blood groups, you don't say it is actually antigen antibody, but you don't say agglutinin, you don't say antigen and antibody directly. In books also it is written antigen antibody. It is better to say agglutinogen and agglutinin. So these are agglutinins or agglutinogens. Now if this question is asked in an objective structure practical examination part of that, then you have to say this is not natural, because these are all artificially made and made to react with the natural agglutinogens. You have done it in the practical classes. So you have this concept now of agglutinogen and agglutinin. Detailed means whatever is in your syllabus, what should be done about blood banking, blood transfusion, blood grouping. Some theoretical aspects will be discussed in the coming 3 days. Coming 3 days means in the time of the practical, in this week only. Tomorrow for one batch. So, but by now you know that these are, when we discussed in the practical, when you did it in the lab, so these are all artificially, this is antisera, which is reacting with the agglutinins in it are reacting with the corresponding agglutinogens present on the surface of human RBCs when we are so these are not regular classes, so there is freedom to enter and leave anytime. Enter at 7:30, leave at 7:35, still it's okay. Is this being done live? Live হচ্ছে না পরে হবে? Live নয় তো পরে. If this is done live, someone may watch it in Facebook. Okay, come for 5 minutes and then again leave. মনে হচ্ছে ভালো হচ্ছে, যাই ঘুরে আসি, but fortunately not live. So these are So this will, and so this is one type of question that may be framed. What are these things? Just identification. Another thing is, what is this? What is this used for? For blood grouping. What type of blood grouping? These things, all these three things taken together, what type of blood groups will it identify? Can it identify? That can be one question. So then you have to answer. So in the theoretical part, it will be discussed. So there are so many types of blood groups. There are not innumerable, but many classifications. But which are discussed primarily ABO system and RH system, because they are the ones which causes the major agglutination, majority of agglutination reactions if in case of mismatched transfusion. Mismatch means a A positive person is receiving some, say, B positive blood, or any negative person is getting, even if the same ABO group, he or she is getting some positive blood. These are mismatched transfusions. Okay, you have an idea about it. Mismatched transfusion, we will discuss it on tomorrow or Friday or Saturday this week. But mismatched transfusion, so these are the major causes of the mismatched transfusion. Major causes mean these two blood groupings. Okay, so that is blood. So ABO and RH typing, these things are used for ABO and RH typing. So trying to sleep. So see, also retain everything. And whenever in the exam you are sometimes asked about instruments. Some instruments are placed, asked to identify. See, if these things are given, sometimes students look blank. There is, at least in instrument part, don't look blank. Many things are written there itself. In many cases, I think you have learnt about the tuning fork in your physics classes. Here it has still not been. That means nothing about tuning fork has been taught in physiology just up till now. But so tuning fork, sometimes it is just asked what is the frequency of the tuning fork. So most of the cases it is written. Most of the cases, no, it is written. It has to be written. Otherwise, because there are specific frequencies to be used for specific purposes, so it has to be written. So if the frequency is asked, then just look at it and say. Don't remain blank. It is a question out of nowhere. I don't know. So you have to use your intelligence and your mind. So this is for ABO blood grouping. And now any related question, there may be a related in auspice, there may be any related question. What is the, if a agglutination reaction is observed with the yellow one but not with the rest, then what is the blood group? Right, you can say. So this is anti-B antibodies. So if the agglutination reaction is occurred with that, then it is blood group B, and not occurred with this, so this is negative. So it is B negative, and not occurred with this, that means it is not A. If with all, then AB positive. These things you know because you have done in the lab. So all these type of questions which are very easy to answer if you think, because you will be given 1 minute, and if you know the topic well, if for any topic, this is a relatively easy topic, but for any topic, if you think for 30 seconds, you will get the answer. Come to a bit of a tougher thing, somewhat tougher. This is not, again, this is not tough. So identification you can do. Now any question may be asked. What is the name of the method? Hemoglobin estimation by which method? So she is finding it funny. Funny though. Not a regular class. Everything is allowed except disturbing others. Even in my regular classes, I allow that. So what is the difference? No difference. There is nothing funny. Why are you laughing? What is the name of the method? Hemoglobin estimation by Sahali's. We had repeatedly told that during naming of the method, you have to name the substance also, which it is formed. Sahali's method, it is written in the book, it is okay, but that is not a complete answer. Sahali's, what is the name of the compound formed? So it is Sahali's acid. So all these types of questions which may be asked in the Viva, in a OSPI, it may be given to written, but usually the answer is less than a sentence, maximum 1 sentence. You have to think and write it within 1 minute. So what is the difference between a pipette and a tube? In this experiment, there is both a pipette and a tube. There is a tube and there is a pipette. What is the difference? It is a difference between a pipette and a tube is not based on its use. It is based on its structure. What is the difference? That is the maximum hint that an examiner may provide you during the viva. But when it is an OSPE, you are just seeing and writing the answer. There is no question of discussion unless you do it among yourselves, among 5 pairs of eyes, including the external examiner looking at you. So what is the difference, structural difference? A pipette is, if you have to draw, that is a use, and from that is the use. But from that concept, you can tell the structural difference also. So if you put the hemoglobin tube, say the open, one side it is open. So if you put it in the bottle of cold drinks and suck, can you? No. But if you use the pipette, maybe you can, because it is open at both ends, and that is the difference between a pipette and a tube. You will come to know of the RBC pipette, WBC pipette in the coming days. All pipettes in ESR PCB estimation, there are, I don't know whether you have heard of this, there is something called the Westergen's pipette and Winthrop's tube. Both are used for ESR estimation. Okay, erythrocyte sedimentation rate, ESR you know by now. Yes, what just at least you have heard erythrocyte sedimentation, although it has not been done in the practicals. But there is a Westergen's pipette and a Winthrop's tube. Pipette is open at both ends, tube is open at one end, obviously can't be closed at two ends, then it makes no sense. So it is open at one end and closed at another. So hemoglobin tube, the tube is there which has graduations. So what type of graduations? Gram per. So all these are done in the practical. You have seen gram percent and only percentage. Gram percentage is the graduation which we use, the percentage is not used. All these may be questions, but usually those discussions, why gram percent, why not percent, these are bit lengthier and it will be asked in vivas. But whenever you cover a topic, you try to think what can be asked as objectives, what can be asked during the viva, and just complete it, more or less. How much it is possible, you complete it. Now, it can be given for how much of blood is drawn in this experiment. See, you can't see the pipette here separately. So if you can see the pipette, if the pipette is only given an image of the pipette, and if it is asked how much of blood is drawn during the experiment, so over the pipette it is labeled that number. But if it is asked from this, you can't see, and so you have to remember how much of blood is drawn for that experiment, 20 microliter. But when you express the hemoglobin, so one of the very common mistakes, or not very common but basic mistakes people are making, I found out during the class also, practical class also. So whenever they are expressing the result at the last, they are saying, okay, it is 15 gram per 20 microliter of blood. So this is wrong. So that is, we are taking 20 microliter, but everything is being standardized and the calculation is coming in the regular units, 15 gram per deciliter or 100 ml of blood. Not that these 15 is in that 20 microliter of blood. So remember that. So I did not think till now that even these mistakes can be made, but in the class someone told me that it is 15 gram in those 20 microliter. What is the blood I have taken? That is no. The graduations are standardized. That is 15 gram per deciliter. We are using, that is 20 microliter, then putting that into the acid hematine is formed. We are diluting it, and then the standardized result by this one of the colorimetric method, matching of colors. So there is a physics and some chemistry behind this, and the result is coming in standard units, that is gram per 100 ml, 15 gram per 100 ml, or 15 means whatever is the figure, 11, 12, 13, 14, 15, and it can be in between 11.2, 11.4, never say odd figures like 11.3 because graduations are uneven, like in case of blood pressure measurement. In blood pressure, the instruments we generally use, graduations are in even 20, 30, 22, 32, 84, but never say 85. Never say means blood pressure obviously can be 85, but not picked up by these graduations. If we measure it directly, direct measurement by putting in the artery, or we measure it by those instruments which are operated by the battery, all these digital instruments, obviously they can show. It can be 84 and it can be 86, it can obviously be 85 also, and in decimals also. Decimals it is not shown, but it can obviously be odd numbers, but it is. So remember these things, these little things during the examination, and these mistakes are common. Okay, mistakes are common and they carry some discredit because you are not applying common sense over there. Whatever you can't see, you are telling. We can't see odd graduations. Now come to a bit of a, sorry. So I think this also we have done, but if somebody has missed or if you don't remember, so in the lab you have to find out that hemoglobin concentration, it will not be given, and then this question may be framed. Now what to do? In the lab you have to find out by experimentally that hemoglobin, and in OSPI part, this hemoglobin will be given. Now calculate the oxygen carrying capacity. For that, what bit of knowledge do you require? That how much oxygen carrying capacity. Now one question, one thing should be written, usually written, that dissolved oxygen should be ignored, because dissolved oxygen in plasma is very less. If it is not written also, you can assume that dissolved oxygen is ignored, and sometimes it may also be given that dissolved oxygen is this much, then calculate. So, but most of the oxygen is carried by hemoglobin. Now from this, see again in this, from this topic in Viva, what can be asked? Anything can be asked. Whatever has been discussed or whatever you should know about the topic. Structure of hemoglobin, how many oxygens can be carried by one hemoglobin, which molecule, which atom means which element is there for that carriage. What is the element in hemoglobin? The element, basic element. Iron. Okay, so iron. Okay, Fe2 plus state. So iron in which state? It can be asked. Iron in which state can be asked as a part of OSPI also, but usually it is a very indirect. So you have to get many hints before that in the OSPI before. So these are usually asked in Viva. How many types of questions can be there in within the same topic you are covering? You read such. For that, I had told that that book by C.L. Ghai is a very good one. You read the questions and answers, you cover everything, almost everything, and then you don't find difficulties. It is not that there is a single book in the world which is contributing like this, but for your level, the books we usually which are circulating in this part of the world, this part of the country, among that book is a very good one for your level. If you covered those things, so I always recommend whatever topics are being taught in the practical class, after reading them for the first time from a book which you have, also refer to that book, the book by C.L. Ghai, and read down the questions and answers. I think for Viva and practical it is enough, and for theory also it is near enough. Even for theoretical writing, if you cover the topic on blood group from that blood grouping, then you can cover everything in the theory also. So very good book. So what bit of knowledge you require here to oxygen carrying capacity, that is how much oxygen, why it is given 15 gram, because how much oxygen is carried by 1 gram, if we know that, then we can calculate. Now 15 gram hemoglobin is in how much of blood? 100 ml. DL means 100 ml. So if we know the oxygen carrying capacity of 1 gram, multiply it by the hemoglobin which is given or which you calculate during the exam, practical exam. So that much oxygen is carried by 100 ml of blood. Simple, because this hemoglobin in grams is also in 100 ml. Now if dissolved oxygen is given, say any arbitrary figure, say 100 ml blood carries 0.5 ml oxygen. I am telling an arbitrary figure. So then you add 0.5 to whatever you get by 15 into that figure, how much hemoglobin, how much oxygen is carried by 1 gram of hemoglobin. So what is that? That is only to be known. Sometimes it is given in the question, but most times it will not be given, because that is a very standard figure, that is 1.34 gram. 1.34 ml per gram. Now 1.34 into 15 will some figure. In the exams, I have repeated in the regular classes, I am repeating, if you don't show the calculation, can't show, it is not a discredit. Although 15 into 1.34 is not a very difficult calculation, but if you don't show the logic, then you will not be awarded any marks. If you just copy from the neighbor, which is a good thing to do, unless you are caught. If you copy, in India copyright means right to copy, like that. In the exam also there is a right to copy, but here copying will not help, you will not be awarded marks. Just copying the value will not help. If you can copy the whole thing, then it helps. Like in the mathematics exams, there were some friends who first asked, I can't do this, please show me. So then the other friend who is capable of doing that is showing. Then that first person is asking, I can't understand the steps, now explain. During the exam is going on. So if you can copy like that by understanding, then it will help. But copying the values in these types of questions, actually you will get 0. No marks will be awarded. Your marks or credit is for the you having the knowledge of that particular thing, not writing the answer. No calculators, no mobiles, don't calculate, you get full marks. But don't show the logic, you get no marks. Okay. Calculation wrong also you get full marks. Wrong calculation by mistake. So opposite of what was taught in school, forgetting the basics. So that should not be. Actually in every step, sometimes opposite. Sometimes in the childhood, for the making the wrong calculations, we were awarded 0, but it is not like that. Now see, the percentage saturation of water, if this is given, then you can, if this thing is given, you can oxygen content also, but usually this may not be given also, because this is also a more or less standard figure. So if the oxygen content is asked, then the value you got over there, you have to calculate 97% of that, because this is also a very standard value. Here it is given in this particular question. So actually the first sentence and the last sentence may frame the question. First and third, 1.34 is not given here, it is usually not given. How much amount, and this is also many a times not given, standard value 97, you have to know. So 97% of that 15, if it is 15 into 1.34 or whatever is given, 12. If you are doing it in the laboratory, you may get say 12.6. So again same thing, 12.6 into 1.34, if you can't do it in your mind, no harm, you just write 12.6 into 1.34, milliliter of oxygen is carried by 100 ml of blood, and 97% of 12.6 into 1.34 is the actual oxygen content. Got it everybody? Okay. So basically these things will help you in the exam, and this is what this class has been conceptualized for, not the whole topic, or I did not understand that topic in the regular class, so discuss that topic for a whole evening. No, not like that. It does not help much. One topic you don't, if we don't understand once, even we may not understand the second time, and everything we cannot remember during the exam. We means at this point of time, it is not possible. MBBS is a vast course, but must know areas are there. Sometimes these classes are good for, these types of classes are good for identifying those must know areas and for the approach to the questions. Sometimes in subjects in school we have to read a lot of subjects, and say somebody says I didn't like history, I didn't like geography. So whatever happens, if in a subject you can't follow properly, then you see the questions at the end of that chapter, or ask your teacher that what questions can be framed out from it, because as a human being it is not possible to follow everything very 100% like that, 80%, 100%. So even if you know 50% of a topic, if you just know what questions can be framed and then make the answers and read the topic, just that, it will not happen in case of all topics. Some topics you can follow well. So this is for everybody. Even the brilliant most student can't understand 100% of all the topics. So if you just know that what questions can be framed for there and just know the answers to that, then if not from the knowledge point of view, from the exam point of view, it is more or less okay. So these are what difficult, somewhat not difficult. That means if you know the concepts or know the, if you have the knowledge, it is not at all difficult. Now, like there, say you have done CVS. Most things in I think CVS is complete. CVS cardiovascular system is complete. Last day arrhythmia was taught. This Monday I think ECG changes in arrhythmia. So more or less complete. Now ECG, if a diagram is given, I don't have ECG diagrams with me right now, but if a diagram, you are asked to identify waves. Now in the auspice there may be, what is the cause of this wave? A wave is pointed out. So what is the cause? Tougher questions may be, so heart rate, but there may be basic questions are at least calculating the heart rate, identifying the wave and knowing the cause, may be asked in, whatever may be asked in OSPI, may be asked in Viva also, but not always the vice versa, because in Viva there is a scope for the examiner to do extensive discussions, that extensive, what is this, what is that, tell me about this, what do you know about this. So that type of, whatever you are writing in the theory paper, a 5 marks answer, that can be also asked in a Viva, explain this thing, explain that thing, but in the OSPI just the objective sentence. So one wave is pointed out, or a not a very common, not commonly found, sometimes found, which wave is not always found, say the U wave. If there is something called the U wave, you will know. So in what type of disease, this is a bit tougher, but if you know it, you can. If you don't know, you lose 1 mark, but 1 mark, losing only 1 mark will not harm you, but every mark is important because it is not very easy to get pass marks. Over here, it is not like that. I got 99 in school, here also I'll get 99, but other questions will be easier. So those are tougher, but if the cause of the P wave is asked or the QRS complex is asked, you should say. So approach like that. ECG is not very easy. For ECG in arrhythmia is absolutely, in our times, we didn't think of these things in the MBBS level, at the MBBS level, but as National Medical Commission has given these competencies, divided the course into various competencies, and in the competencies it is mentioned, so we have to discuss now. ECG in arrhythmia, ECG in those heart blocks, I think you have, sir has discussed these things, ECG in heart blocks, Mobitz type 1, type 2, but these are tougher things. But at least, and examiners in physiology, examiners won't usually ask these things in Viva. But as these are in the syllabus, if the examiner wants, he or she can frame a OSPI, usually not asked in the Viva, these tough things, or as this is in the syllabus, we don't know who will frame the question during the university exam, short note. As this is, it is mentioned in the syllabus, we can't do anything about it. There is something in amphibian physiology which we'll discuss after this first internal is over. So amphibian physiology, the practical part, there is one part is nerve muscle physiology, amphibian physiology, and one discussion on nerve muscle related to nerve muscle physiology, discussion on cardiovascular. Cardiovascular is not very easy, and it is, we didn't discuss it in the last year also, but one examiner was asking that these things should be taught and these things should be asked. And so we told that these are usually very tough for the MBBS students, so we don't know. So that was left, but we will discuss this time. So because as it is mentioned in those competencies now, in our times there was a advantage, there was a disadvantage also. Disadvantage was that even the teachers didn't know how much to go, and we also didn't know. So there was a accepted things that these should be asked in MBBS, these should not be done, and it was done like that. And advantage was that most of the times those accepted norms were followed by most paper setters and all, but now there is a fixed, in those competencies whatever is given, if a person thinks okay this should be done because this is in these competencies, so however tough it may be, this should be asked, so questions may be framed. So you should know about those things like that, but no scope of discussing thoroughly in this period of time. But whatever is in the competencies, at the end of the year when you are revising, say after the second internal assessment, when you are going to face the third internal assessment and the final exam. So you are revising, reading new things before the third internal assessment, new things also, revising the whole things from the whole year. I always say go by those competencies. No one will see from outside the external examiner whether your college has taught it or not. If you have missed out something, come to the teachers like this. In a professional course, nobody will feed us. As students, nobody. We can't expect that everything will be fed. In biochemistry syllabus, I just giving an example. So vitamins and minerals are there in the syllabus. So I think, I don't know whether they have omitted basic things. You are reading from school, from the school level. From the school level. So I think in our times those things were not taught because the syllabus itself, it is so short time, 9 months, 10 months. So it could not be covered. Okay, one student was asking me about action potential, these things. Monophasic action potential is what is monophasic, biphasic? You concentrate on monophasic only. Has biphasic action potential, all these been discussed? General physiology, nerve muscle physiology? করেছেন তাহলে কিছুটা হয়তো জানো even we don't focus much on that. Actually whatever you see, the standard, what is written in the standard but your textbooks you follow, and whatever is important from the exam point of view, all these are monophasic. So if a question comes, features of a monophasic action potential, don't get afraid. Whatever you are reading normally about the action potential, that is that thing. Biphasic action potential is actually very, this one wave, another wave is the mirror image of that one, like that. See, biphasic, two waves. If experimentally placing the electrodes in the same fluid, either inside the cell or outside the cell. Now tell me, what is resting membrane potential? Definition can be asked in the viva, in the theory. What do you know? Or explain the term resting membrane potential, 2 marks or 3 marks. If it is 3 marks, then you have to give some examples also. For this nerve cell, it is such and such, minus 90 millivolt, minus 60 millivolt. These are figures like that. But what is resting membrane potential? Action potential develops from, that concept develops from there only. Resting membrane potential, the definition comes from the words only. What is resting membrane potential? Who can say? You? What's your name? Don't need to stand. Sit and say. Name, what is your name? Deba? So do you know the definition of resting membrane potential? Yes, almost correct, but we should frame it properly. Cell membrane, inside the membrane, it is more negative or more positive? Potential across the cell membrane is almost correct, it is but you have to say one or two more things. In most animal cells, the definition is, most animal cells, there is a difference of potential across the, or difference of electrical charges across the, or on the two sides of the cell membrane. Animal cells don't have a cell wall, so cell membrane, where usually the interior is negative with respect to the exterior. Which ion is responsible for that? If 3 marks is there, you write all these things. Okay. Sometimes we have to frame essays, so everything is important in life. Okay. I didn't like history, but history was a good subject to learn framing essays. I know 2 lines and I frame 5 lines. With no disrespect to any the subject, that means we did these things. So in resting membrane potential, if you say about just specifically definition, most animal cells, there is a difference of potential, difference of electrical charges on the 2 sides of the membrane, where usually the interior is negative with respect to the exterior. This difference in potential across the membrane is called the resting membrane potential. Now, if there are 3 marks, you write these ions, usually sodium, potassium, responsible for it, and examples in some types of cells. In nerve cell it is like that, in muscle cell it is like that. So you go write like that. Now, what is action potential? Action potential is rapid change in this resting membrane potential. Rapid change in membrane potential followed by return to the original level. You have seen about the action potential, like, I don't know whether I have brought it now. No, I have not brought it. See, like this. This is waveforms, that means triphasic also. But forget that. Usually what you have read about the action potential, it's monophasic. So features of an question is features of a monophasic action potential. Say you haven't heard that term, monophasic, what is this? Something else, I don't know, 5 marks I leave. These cannot be done during the exam. This is absolutely not allowed for your own self. Leaving 5 marks, I have not heard. Then you write whatever you know about the action potential, that is what is required, mostly. So again, in this case, it is not exactly mirror image, there are various causes for that. So don't need, you just concentrate whatever you know about the action potential, monophasic, biphasic. Biphasic is actually experimentally if the 2 electrodes are placed inside the extracellular fluid, or it may be the reverse, both electrodes in the intracellular fluid and measured like that. But a single electrode or a nerve is cut in the middle, and inside is there one excited. Only one electrode, a monophasic, can be recorded. Whatever you have read about the action potential, you write like that. There is something called this thing was being asked by me by a student today, not attended, because I told that this type of classes is not for discussing a topic. So may have felt that there is no use going. Sir has already told won't discuss. So, but just see compound action potential. There is something called is not labeled. This is something called the compound action potential is between. There are considering various neurons, various nerve actions. Action potential occurs in which part of the nerve? It is recorded from action, not action, axon, AXON, axon. So some fibers will be slow conducting, some fibers will be a medium type average, and some will be fast conducting. The classification of nerves is there in your syllabus is there, because nerve physiology has already been done. Type 1A, type 1B like this, already discussed, or type ABC. Classification of nerve fibers are given in the book. Nerve physiology has already been started, and I think these things may have been discussed, and should have been discussed. Then what has been discussed in nerve physiology? Already started. These potentials have been resting. What is equilibrium potential? The potential at which ion efflux and ion deflux across a cell membrane is equal. That is equilibrium potential. Electrochemical gradient, these things also in general physiology also. All these things are related. General physiology, nerve muscle physiology, these things are related. Muscle has not been started, but nerve physiology, so classification of nerve fibers should have been done. If not done, won't be asked in the exam, but I think in the introductory classes on nerve physiology, types of nerve fibers, type 1A, 1B, some are slow conducting, some are slow. So the compound action potential are fast, but it is a diagram is formed where it will be showing this average or some effect of all these types of fibers taken together. Don't need to go into the details. So that type of thing. So monophasic, biphasic, don't get perplexed by these things. You concentrate on whatever you are reading about the action potential as a whole. Resting membrane potential definition can be asked, action potential definition and the characteristics, which part of the wave, depolarization, repolarization, for which part of the wave represents what and why, which ion is responsible, all these things. Whatever these simple things, as you know it, you write it. Okay. So we have, I just deviated from that where I told that CVS has been done. So CVS has been done, and I just went into ECG, but I was going to talk about blood pressure. Also blood pressure has been taught in the practical exam. So what is your opinion now? You should tell these things. How do how do we perform this blood pressure? How do we measure? So during auscultatory method, palpatory method is simpler, only get the systolic blood pressure, no stethoscope is used. Auscultatory method, so it is based on the hearing of those sounds, and then again appearance of the sounds and disappearance of the sounds. So a question may be framed after whenever we constrict an artery. So this is the principle is constrict an artery, and whenever blood flow is coming back, again deflate the cuff, blood flow is coming back to the artery. In this case, usually we do it over the brachial artery. We tie the cuff over the arm, so the brachial artery. So over whenever blood flow is restored through an artery, this is the principle, sounds are produced. But are sounds produced during normally blood flowing through the vessels? No. Arteries, veins, wherever, no sound. So, sounds are produced after constriction of an artery if the blood flow is restored. Explain. Explain why type of question. Okay. So, these things may be also. So, this is, so whenever you read the topic blood pressure, don't just, okay, I know how to see the pressure, okay, I'll say this much I got, this much I got looking, but you complete the topic, whatever can be asked in auspice. These one, say one objective structure, in auspice, MCQs are also there, MCQ type of questions. All these are true about measurement of blood pressure except, say one line is there, that will, which is the answer I am telling. So, there are various, some are false statements, say 4 or 5 options, some are false statements. So, very, say a very stupid thing to say, diastolic blood pressure is greater than systolic blood pressure, that is false. So, but before measurement of blood pressure, the person has to rest for 5 to 10 minutes. This is true. Like this, there will be an option which is true. So, all these are true except there will be one false statement. Like this MCQ type. So, whenever you read the topic, how to measure blood pressure, what are the precautions taken, if we measure in sitting position, then the person's feet should be touching all these things, tea, coffee, that means smoking should be avoided at least 1 hour before the measurement, all these things, okay. So, all times it is not possible to give 5 minutes rest, but that is a protocol. So, covering all these, there may be objective structured questions. Now, have you read about, in general physiology, I think you have read about homeostasis in the first classes, initial classes, body fluid compartments, homeostasis, these are important topics. Don't forget body fluid compartments, how it is divided. 60% is total body water, out of that how much is ICF, ECF, these things you know. If you have forgotten, read it again. Okay, ICF, intracellular fluid, and measurement of those. That can be a long question in itself. What are the different body fluid compartments? Then explain this and how to measure. We measure using various substances. So, like extracellular fluid cannot be some things, some of the components cannot be measured directly. So, total body water minus this component is another component. Like this, everything is there. So, this. Now, in homeostasis, one important concept is about feedback control. What is feedback? What is feedback? Even endocrine physiology has been started. What is feedback? What is it? Feedback is response or a signal response formed or produced at some organ or system of the body, usually due to some event in some other place, in some other organ or system, in some other part of the body. Usually that event is undesired and taking some parameter outside the physiological limits. Feedback is that thing, that feedback is an signal produced at an organ or system, say thyroid hormones has decreased. So, that signal will be sent to the pituitary. So, the problem is in the blood, and now the signal is going to the pituitary to secrete more TSH. That some parameter is going out of physiological range to restore that to the desired limit. Now, see, now there are control systems. Now, that organ, that signal will activate the control system. Now, very basic examples. What in your syllabus, what have been discussed? One example from there. Say, systolic blood pressure of a person is 100 mercury. Now, sudden fall in blood pressure in there due to any reason, huge fluid loss, that means huge blood loss or something, any reason is not it. So, it is going to 40 millimeter of mercury. This is what is happening this is not in our control. It is going because there is fluid loss. So now it will not be sufficient to circulate blood in the body, heart, everything, mechanism, the whole cardiovascular baroreceptors are there. We have already read about baroreceptors. So baroreceptors are there for restoring. Now baroreceptor mechanism is restoring it to, so it does not allow it to fall to 40. It cannot take it up to 100, but it is at least trying, and it is taking it up to 80, so that there is no gross derangement. Even 80 systolic pressure is that place where this signal is coming. That is, the feedback is controlled by this, that there the control system is activated. So this is coming up to 80. Okay. So now, so the correction is, how much is the correction? How much is the correction? Correction is 80 minus 40. That is 40. But how much correction cannot be made? See from the figures. No, how much correction cannot be made? What was the desired? Huh? How much? So this is called. So sometimes if problem based questions this may come, I don't know whether you remember it. These things should have been discussed in the introductory classes, and even if discussed, you not discussed these things. So this is called error. Okay, you know, problem based question. This is called error. So this is error. So a control system will make some correction, but still it will have some error. So this is called correction. This is the correction 40 mm Hg, and now there is a term called gain. Okay, gain equals to correction by error. That is, in this case, it is 40 by 20. It is 2. So greater this figure, more effective is the. You see, if it is say it can correct up to 99. So if it can correct about 99, it will be 40 by 1. It is 40. You get it? It has corrected up to 80. If it can take it up to 99, then the error is just one concept, and so as there are mathematical calculations, it can come as a problem solving question, right? Take another example from the respiratory system, although respiratory system has not been discussed. It is not very difficult to understand. Carbon dioxide is in venous blood is say carbon dioxide is okay, partial pressure of carbon. Leave the unit. There is a unit, but for now, just for the sake of understanding, leave the units also. There will be units. Obviously, there will be units. Partial pressure. As you have not done the respiratory system, leave the units for now. Blood pressure example which I gave, you have know the units. For now, say that there is a value of 36 venous carbon dioxide. It has gone up to 60 because of any mechanism, respiration is or some metabolic activity or something like that. It has gone up to 60. Now, body is correcting it from 60. It comes down to 40 by ventilation, hyperventilation. Whenever carbon dioxide integrates, hyperventilation means ventilation term, perfusion term, all these terms will come in the respiratory physiology. Ventilation means there is higher, this breathing rate, depth, everything increases. So ventilation is more. So this is correcting up to 40. So what is the C? What is C over here? Correction is 20. And what cannot be corrected? Error is what was desired? Error is 36, it was there, but it has corrected up to 40. So minus 4, you leave it, that is. Because desired was 36. So this is gain is Gain of this control system. What is the control system? The mechanisms which are activating hyperventilation, which are activating ventilating mechanism. So gain is 5. Again, see, if the correction was up to say 37, so it would be just 1, 20 by 1 is 20. If the gain is more effective is the system. So these are two examples. So sometimes actually in general physiology and CVS physiology, some things are overlapping. And if this has not been discussed also, just know this, it is given in the books. In your books you will read what is gain of a control system. You read that. It is important for both concepts and from the exam point of view for problem solving questions. I discussed due to that reason only, because it can come as problems. Want to come, you can come. So whatever is discussed today, think about these things, and from all topics try to think rationally and as a whole, not just blood pressure only I know how to measure and nothing else. So try to think rationally and cover that topic as a whole. And after you read renal physiology, respiratory physiology, you can relate to this CVS. Not done till now. For now, whatever has been taught, when you cover a topic, because physiology is mainly on concepts, not much to, there are things to memorize. In endocrine physiology, question is that what hormones are secreted from the arcuate nucleus of the hypothalamus, no concept in that. But mostly it is based on concepts, so try to